Hello, mabuhay, maradyaw na adlaw, maayong buntag. Our premiere math video is about a very common math problem, maximizing the volume of a box. A square of side x inches is cut out of each corner of an 11 inches by 8 inches piece of cardboard. The resulting sides are then folded up to form an open-topped box. How large of an x should you cut out of each corner in order to maximize the volume of the box? Justify your response. What is the maximum volume of the box? First, we need to sketch a diagram of the rectangular cardboard and mark the square cutout of length x in each corner of the rectangle. I have already pre-drawn it. Okay, so let's continue labeling x here in the remaining two corners. Okay, so what does this mean now? If we are going to remove these squares on this side, the 11 inches now becomes 11 minus 2x. The same way, for this side, if we remove those two squares, the 8 inches now becomes 8 minus 2x. After we remove the x's on the four corners, we are going to come up with this figure here on the left with dimensions of 11 minus 2x, 8 minus 2x, and x. And if we're going to fold the sides up, we are going to form the box, the open top box here on the right. Let's label the dimension of the box. So this will be our height x, our length is 11 minus 2x, and our width is 8 minus 2x. Let's write the volume of the box as a function of x. This will be v of x is equal to 8 minus 2x times 11 minus 2x times x cubic inches. Now we might ask, how large should our x be? Can we just draw any square size? Obviously not, otherwise we're going to eliminate our rectangle. So let's determine the domain of v as a function of x, taking into account the restriction that the model imposes in x. So we said x is to be greater than 0. Okay, let us equate x minus 2x greater than 0. Subtract both sides by 8. That should give us negative 2x minus 8. Then divide both sides by negative 2. So x, now remember we're dividing by a negative number. So let's switch the inequality, sense of inequality. That should give us x is less than 4. Does this make sense? If this is greater than 4, then 8 minus 2x will be in the negative range, and that would make our everything undefined. So this makes sense. Now let's check 11 minus 2x greater than 0. Subtract both sides by 11. 2x greater than negative 11. Same way, divide both sides by negative 2. X is less than 5.5. Now, where do these three sets, x greater than 0, x less than 4, x less than 5.5, intersect? Let's say this is your x greater than 0. Let's say x less than 4. and x less than 5.5. As you can see, the three sets intersect between 0 and 4. What does that mean? That means that our domain is between 0 and 4, excluding 0 and 4. Now that we have our v of x and we determine the domain, how do we find the value of x and the maximum volume of the box? We will try to do this in two ways. If you are taking high school algebra, this can easily be done using graphical methods with the help of technology. I am going to demonstrate using a graphing calculator. First, press y equals and enter, and type in your function y equals 11 minus 2x times 8 minus 2x times x. Then you are going to press zoom 6 to see our graph. We cannot clearly see the graph, so we're going to adjust our window. Our domain is between 0 and 4, so let's change our x-min to -2, x-max to 10. Let's increase our vertical axis since we're looking for the maximum volume of v of x. Then you're going to press second trace 4. Our prompt is asking us for the left bound. All you need to do is move the cursor to the left of the highest point and then click enter. Right bound, move the cursor to the right of the peak and then press enter. Guess, enter. So the output shows the coordinates of x and y of the maximum point. What does this mean? This means that the side length of the square cut out must be around 1 and 525 thousandths in order to get a maximum volume of about 60 and 13 thousandths cubic inches. If you are taking calculus, we can find the maximum volume using derivatives. Derivative is the instantaneous rate of change of v of x at a point. In other words, it's the slope of the tangent line to a curve at point x, v of x. But first, let's expand our v of x. We're going to multiply 11 minus 2x and 8 minus 2x using distributive property and then distribute x. That should combine like terms. That should give us 88 minus 38x plus 4x squared, and then multiply each term by x. Our v of x in expanded form should be 88x minus 38x squared plus 4x cubed. Now let's take the derivative of v of x and equate it to 0, since the instantaneous rate of change at a specific point is the same as the tangent line slope. The resulting function is a quadratic equation. So let's use the quadratic formula so that high school students who have not yet taken calculus will have access to our content. It always helps to first identify the values of A, B, and C. Okay, now substitute the values to the formula. X equals negative B plus minus the square root of B squared minus 4AC divided by 2A. You cannot graduate high school without mastering the use of this formula. Okay, let's substitute. So X equals negative, RB is negative 76. So it would be negative times negative 76 plus minus the square root of quantity negative 76 squared minus 4AC. So our A is 12 times C 88 divided by, okay, make sure you extend the line, divided by 2 times A, which is 12. That should give us X equals positive 76 plus minus the square root of 1552 divided by 24. Okay, so let's take the two values of X. Let's first have X, the plus and minus. X equals 76 plus the square root of 1552, which should be around 39, and 395432121. Check your calculator, divided by 24. Okay, and that should give us X is equal to 76 plus 39.39543 divided by 24, and the negative, for the negative you have X equals 76 minus 39.39543 to 1 divided by 24. For the first value of X, we should get X is approximately 4 and 81 hundredths inches. We're going to reject this value because remember our domain was between 0 and 4. So this is beyond our domain. That would give us a negative range in the X values or side length of our square. So for X, for the negative, so X equals 76 minus 39.3954312 divided by 24, we should get X about 1 and 53 hundredths inches. That's the side length of the cutout square. Now let's find the maximum volume of our open top box using algebraic method by just simply substituting the X that we obtained beforehand to the original V of X. So it will be 88 minus 38 times the value of X squared plus 4 times the value of X cubed. That should give us a maximum volume of approximately 60 and 1 hundredths cubic inches. Exactly the same as the one we got using graphical method. That's it for today. I hope you learned something from today's presentation. Please do subscribe and hit the bell button so that you'll get notifications for our next math video. Do you have questions? Ask Mary G by writing your question below this video. Also comment below if you need a paper copy of the actual solution script or calculator keystrokes. Indicate where to send the document, be it email or FB Messenger. Okay, remember, math is beautiful.